right, so Chapter 8, Lesson 3 is Functions and Equations. The one-up says, the table shows the amount of money Carly earns based on the number of hours she babysits. We want to write a sentence that describes the relationship between the number of hours she babysits and her earnings. So here, when we're looking at this relationship, we're looking at the relationship, how do I get from X to Y? How do I get from X to Y? Okay? So, how do I get from 1 to 6, 2 to 12, 3 to 18? What's happening?
You're multiplying by 6.
Very good. So here, and you're going to write a sentence, right? She earns $6 for every hour she babysits. Okay? The second question says, does she earn the same amount each hour? Well, yeah, because she earns $6 per hour. Very good. So, yes. Her earnings increase by the same amount every hour she babysits. So here, we are going to write an equation to represent a function. Please make sure you write down your heading. You can use an equation to represent a function. The input, or the independent variable, represents the x value. The input, or the independent variable, represents the x value. The output, the output, or the dependent variable, represents the y value. Okay? So that x and that y, they have three names. Okay? So you can call it the x value, you can call it the input, or you can call it the independent variable. Those all represent the same thing, the x value, the first one. The output, or the y value, the y value, the output, or the dependent variable. Those all three represent the same thing. Okay? It says an equation expresses the dependent variable in terms of the independent variable. Alright, so example 1 says, write an equation to represent the function shown in the table. Now, first of all, I just want to tell you guys, these are two different ways that you can write your table, okay? Here we have a horizontal table, and here we have the vertical table, okay? Either way is fine, but I'm going to go ahead and talk on the vertical table. So, the first thing we want to do when we write an equation is we want to see how does the y value change, okay? So here, going from 9 to 18, 18 to 27, 27 to 36, and 36 to 45, each time we're going to add 9. Very good. When you are looking at how your y value changes, it has to be the same. Okay? At this point, it has to be the same. So, I know that you can go from 9 to 18 by multiplying times 2, right? But, can I go from 18 to 27 by multiplying times 2?
No.
No. Can I go from 27 to 36 by multiplying by 2?
No.
No. So that does not work. You got that? They have to be the same. So here we're adding 9 each time. Then, what are we going to do with that information? Well, we are going to take that 9, and that 9 gets multiplied by the input. Okay? So, once you multiply that 9 times the x value, you will get the y value. So the equation is y is equal to 9x. So for the got it, it says write an equation to represent the function shown in the table. I want you to write the direction and copy down the table because we are going to show our work on the table. Alright, so once again, we want to look to see how the y value is changing. Okay? So we're looking at how to go from 16 to 32, 32 to 48, 48 to 64, and 64 to 80. So how does it change?
Adding 16.
Very good. We're adding 16 each time. Okay? So we're adding 16 each time. What am I going to do with that 16? Now that 16 gets multiplied by the input. So now you're going to multiply the change in y by the input. So we're going to multiply that 16 times the x value. And when I multiply the 16 times the x, that's going to be equal to the y value. This is your final equation. So now we're going to graph linear functions. Okay? If the graph is a line, if you're graphing and it is a line, the function is then called a linear function. Please make sure you write down that definition. When graphing a function, the input is the x-coordinate and the output is the y-coordinate. So, I want you to write down the definition for the linear equation or the linear function. See, if the graph is a line, a straight line, then the function is called a linear equation. Now, when we said that the x-coordinate is the input and the y-coordinate is the output, look at what we have here. Do you remember this? Input, comma, output, or x, comma, y, that is called a what? Starts with a C. Coordinate. Oh, no, I'm sorry, it starts with an O. Ordered pair. Very good. It's an ordered pair. Very good. So this is an ordered pair. So for example 2, it says we want to graph y is equal to 2x. Now, here we have step 1 and step 2. Step 1 is to make a table of ordered pairs. When you make the table of ordered pairs, of course, you're going to choose your x values, then you will substitute and simplify to get your y values. Okay? Step 2 then, after you get your ordered pairs, is to graph each ordered pair. So, here we have y is equal to 2x. The rule here, the function rule, is 2x. Is everyone with me? So that is the middle part of your table, the middle column in your table. So now you're going to choose your x values. Now, I want to tell you, okay, when you are graphing, choose appropriate x values, okay? Choose appropriate x values. You're not going to want to choose 150 times 2, right? Because you're going to have to graph 150 comma something, right? 150 comma 300. Is everybody clear? You don't want to graph that. So, graph it. Keep your graph small. 0, 1, and 2. Maybe 0, 1, 2, and 3. Okay? So, once you choose your x values, then you substitute and you simplify. So 2 times 0 is 0, 2 times 1 is 2, and 2 times 2 is 4. Now you can see we have an ordered pair. So this ordered pair, 0, 0, 0, 0, we get from here, 0, 0. This ordered pair, 1, 2, we get from 1, 2. And then this 2, 4, we get from 2, 4. Is everybody clear? Yeah. And then you graph. Here we have 0, 0, 1, 2, 2, 4. And then you draw your line. So, for got it letter B, we're going to graph y is equal to x plus 1. Okay? So here I chose 0, 1, 2, and 3. Those will be my input values. Okay? And now we're just going to substitute those input values into the function rule, simplify, and then we'll get our y values. So 0 goes in for x. So that's going to be 0 plus 1. And that's going to be equal to 1. 1 goes in for x. So that's 1 plus 1. That's equal to 2. 2 goes in for x. 2 plus 1, 3. And finally, 3 goes in for x. X3 plus 1, which is 4. And that's how you complete your function table. Now, from that function table, we have our ordered pairs, right? X comma y. So my first ordered pair is 0 comma 1, right? 0 comma 1. The next one is 1 comma 2. And the next one is 2 comma 3. And the last one is 3 comma 4. These are the ordered pairs that you will graph. So now you can graph your ordered pairs. So here we have 0 comma 1. 0 comma 1 is right there. 1 comma 2 is right there. 2 comma 3 right there. And then 3 comma 4 right there. So we plotted our points, and now all you have to do is draw your line. Oops. All you have to do is draw your line. And of course, if you have a straight line, what kind of function is this? Linear function. Very good. This is a linear function. Or a linear equation. You say linear function or linear equation, same thing. Okay? And of course, that we know that because this is a straight line. Is everybody clear? All right, so do letter C, and then I'll show you the solution. So here, I already chose 0, 1, and 2 for your function table. We're going to substitute and simplify. So for 0, we have 3 times 0 plus 2 equals 2. For 1, we have 3 times 1 is 3, plus 2 is 5. X equals 2. 3 times 2 is 6, plus 2 is 8. Is everybody clear with that? And then when you graph, this is what your graph looks like. So we're graphing 0, 2, 1, 5, and then 2, 8 is 5, 6, 7, 8 right up there. You see that? And then we have a straight line, so this is a linear function. All right, example D says the graph shows the amount y that you spend if you buy 1 book and X magazines. We want to make a function table for the input-output values. Write an equation from the graph that could be used to find the total amount if you buy 1 book and X magazines. Okay? So this one is working backwards again. Okay? This one you have to show your work using inverse operation. Okay? So here, what are my X and Y values? We gotta look at the graph, right?
Yeah.
So, what are the coordinates for that point? 1, 20. What are the coordinates for that one?
2, 25.
Good. 2, 25. How about that one?
3,
Good. 3, 30. And then the last one,
4, 35.
very good, 4, 35. Now, to write our equation, we want to look at how the y value changes, okay? So, how do I go from 20 to 25, 25 to 30, 30 to 35?
Add 5.
You're going to add 5. Very good. So now, what do I do with that 5? Take that 5 and we multiply it. Whoops.
Input.
Very good. We're going to take that 5 and we're going to multiply it times the input, right? Okay. So we get y is equal to 5x, right? Wait a second. 5 times 1 is 5, not 20. 5 times 2 is 10, not 25. How do I get to 20 after I multiply times 1? What do you think I need to do? You need to add 15. Very good. So, here we have 5x plus 15. So now we can check to see if each one of those works. So let's call this part making adjustments, okay? Let's call this make adjustments. Okay, so now that you've made that adjustment and you have your equation, we need to check to make sure that we do actually get that y value. So the first thing we want to do, let's see, we want to substitute 5 times 1 and then add 15. And of course, 5 times 1 is 5 plus 15, 20. Good, that works. So let's try for x equals 2. So 5 times 2 is 10 plus 15 is 25. Check. Oops. And then let's check for x equals 3. So 5 times 3 is 15 plus another 15. That is equal to 30. Check. And then lastly, let's check for x equals 4. So 5 times 4 is 20 plus 15 is equal to 35. And we got them all right.